Welcome everyone to Verzeo YouTube channel. My name is Saurabh and today I'll be talking about machine learning careers. So we'll be focusing on machine learning engineer skills. Basically what are the skills required in order to become a machine learning engineer? How can you become a machine learning engineer? What are the steps? Then we'll be focusing on, a typical job description. So all those things we'll be covering in this particular video, right? The career aspect of machine learning engineer. Now, who can watch this video? Basically anyone who wants to become a machine learning engineer. You can be from an analytics background or an ETL domain. You can also be a BI developer, or you can also be a fresher who wants to make a career in machine learning, right? Before I move forward, guys, let me tell you a bit about Verzeo. Verzeo is basically India's largest internship and certification platform, right? This is the website verzeo.in. Now you go to programs, go to pro degree and select machine learning, and you'll be landing on the machine learning certification page. You can also check out all different types of certifications which are available, which I'll be talking in detail later in the session. For now, let's focus on today's agenda. So guys, this is what we'll be discussing today. We'll begin by understanding, what exactly is machine learning. We'll not go into too much details here. I'll be coming up with a separate tutorial on machine learning. But for now, I'll just give you a quick introduction to what exactly machine learning is, right? And what are the different types of algorithms available. Again, I'm saying I won't go into too much details or the technical details of machine learning, right? I'll be coming up with a separate tutorial on that. But for now, I'll just give you a small introduction about it. Then we are going to understand who exactly is a machine learning engineer. What is the typical day-to-day activity of a machine learning engineer looks like. After that, we are going to understand what is the industry requirement for a machine learning engineer. What type of skills industries look for in a machine learning engineer. So we're going to discuss all that, and then finally we're going to talk about how you can become a machine learning engineer. What are the steps that are involved in order to become a successful ML professional, right? After that, I'm going to talk a bit about machine learning salary and how does the future for this particular domain looks like, right? So let's quickly move forward, guys, and understand what exactly is machine learning. So what is machine learning? Now, machine learning in a nutshell is basically, mimicking a human brain inside a machine. Or if I have to be more specific, I can say that I want to create an algorithm that can train my machine in such a way that it can automatically think on its own, analyze and make decisions, right? So that's what my entire idea of creating a machine learning model or a machine learning software is, right? So that I don't have to hard code each and everything my machine can learn on its own. So deep learning and machine learning are nothing but subsets of artificial intelligence or ways to achieve artificial intelligence. And the idea behind it is to make our machines smarter, basically giving them the power to think, analyze, and make decisions on its own, right? So let's move forward, guys, and we're going to look how exactly it's worked. I won't go again into too much detail here. I'll be coming up with a separate tutorial on it. But just to give you an idea, what happens is you have a data set, right? And you feed that data set to a particular algorithm. That algorithm trains itself on that particular data set. And then after that, you test that algorithm with a different data set, right? Then you test the algorithm and then you figure out the accuracy. Now, let me just explain you with an example. Suppose you want to create a recommendation engine. Now, how do you think recommendation engines work, right? So you must have noticed when you go to Amazon, purchase an iPhone today, tomorrow you'll see a recommendation, an Amazon product recommendation of an iPhone cover or maybe an iPhone charger. Or if you go and watch a horror film today on Netflix, it will again recommend you certain movies which are pretty much in that genre, right? So how do you think that happens? That happens because of machine learning. So what happens here is, for example, if I take the case of Netflix, how does Netflix recommend you certain movies? What happens? It will track your each and every data point, each and every movement that you make on that particular app. It will track that, right? And based on your history, movies that you have watched, or whatever movies that you have previously watched, it will recommend you certain movies. What it will do, it will basically create clusters of people with similar interests, right? For example, there can be 10 people who like horror movies. There can be 30 people who are more into adventure and action type of movies, right? So accordingly, it will recommend certain products based on the clusters where you lie, right? Now, how do you think that is happening? It is happening because somebody has trained a machine or a software on your data, and that software was able to create a cluster of people with similar interests or similar traits, so that you can recommend certain products to that particular cluster. Now let's focus on the diagram which is there in front of your screen. So just notice that here you have a data set. So data usually comes in a very raw format, right? Before you feed into your algorithm or you start training your model, you have to perform a lot of operations. We basically call it as pre-processing of your data set, right? You might have to clean the data. There might be a lot of inconsistencies, certain missing records, certain records are missing, or maybe certain useless columns are there, right? So all these things you have to remove first. Then what you have to do is you have to understand, what are the features or what are the columns which are important for me, right? So, for example, if I want to predict what will be the sales of Amazon next year, so obviously this year, last year, and probably historical data of sales year on year is very important for me, right? But at the same time, it is not important for me to look at what type of transactions are happening. There might be a column in my data set, but which basically tells what type of the payment option was selected by a user. Now, that particular column is totally useless if I want to predict the sales that's going to happen next year, right? So you have to understand what are the features, what are the important columns which are essential in order to predict a certain thing, maybe sales, maybe how many app downloads which will happen. So all those things, if you want to predict, that will only happen once you decide on what columns are important for you. Now, once you have done that, pre-processing of your data set is done. You divide it usually into two parts, training and testing. So you keep around 70% of your data set as your testing data set, and 30% you keep it for testing. Now, this training data set you feed into your algorithm. Algorithm trains itself on that training data. And then after that, you feed in the testing data to that algorithm in order to evaluate how accurate your result is, right? So that's how typically it functions. Now, if I take that sales example again, if I want to predict how my sales is going to perform in 2022, what I can do is I can create this training and testing data set of historical sales and other important columns, right? Based on this trained model. So I'll feed in that testing data to that algorithm, and it will tell me how accurate the trained model is. So how it's going to do that, it's a complete technical process and maths behind it. You don't have to go there. But in a nutshell, if I have to tell you, there's a data set which has to be cleaned. You have to understand what the important features, basically pre-processing your data set, feeding it to an algorithm so that it can train itself on that particular data set. And then finally, we use the testing data in order to evaluate how accurate our model is. Now, at the same time, if you can also understand it with an analogy. Now, when a newborn baby, a human baby or an animal, or probably a puppy or maybe even a cub. So how do you think a newborn baby learns? It learns on its own also, right? Sometimes, don't have to teach everything to that particular kid. So whenever it touches fire, it will know, okay, this is not something he's supposed to do. So what is happening here? He or she is, that baby is basically collecting data around him. She's collecting that data in his brain, and based on whatever results that come out, he's taking certain actions around it. It's a very clear analogy, guys, and that's what the goal of machine learning is, to mimic the human brain inside a machine. There can be multiple types of machine learning algorithms. So there are two methods of categorizing a machine learning algorithm. Either it can be supervised, unsupervised reinforcement, or you can also classify it as regression, classification, and clustering. Now, in a nutshell, if I have to tell you, regression problems are ones where you have to predict sales in the next year, or and how my sales is going to look like after 5 years, right? So that prediction part where you have to predict how my sales is going to happen, or how many app downloads will I get, or how many sessions will I get on my web page, where this prediction is happening, and then there's sort of a linear availability. So at that time, you usually choose regression algorithms like linear and logistic regressions. Classification is used. Classification algorithms like a random forest, decision tree. So all these algorithms are used when you want to classify something. For example, you want to know whether this flower belongs to this species or the other species, the X species or the Y species, whether it will rain today or not. So there are only so you have to classify things, right? Whether the given image is of a dog or a cat, right? So that sort of classification where you have to classify into multiple classes, maybe A, B, C, D, E. It can be classes can also be flowers. It can classification can also happen for the weather forecast, whether it will rain or not. So all those things where you classify certain things is basically falls under classification algorithms. Now clustering is basically when you create clusters. So if you remember, I just discussed about the Amazon product recommendation, right? So that happens because of clustering, where you create clusters of people with similar interests. And yeah, that is basically what clustering is. There's a very famous algorithm called K-means clustering algorithm. Now, the other way to categorize it as supervised, unsupervised, and reinforcement, where supervised is when your data set contains the actual prediction numbers. For example, if I'm predicting the sales in 2022, I know the sales data of all the previous years from 2020, from 2019 till 1994, or 1994 to 2019, right? So I have that historical data. with the output also which I want to predict, right? Sales in that particular year. I know that, right? So that is basically what supervised learning algorithms are. Unsupervised learning is basically, you can say, when I'm creating clusters, right? Clustering algorithms, which I just discussed. So over there, I don't have the accurate record of, okay, this person will watch this particular thing. Or you can say that everything is not dependent on your historical data also. It also depends on people like you with similar interests, what are they doing. So when you actually don't know what you're going to predict, that falls under unsupervised category. Reinforcement is essentially when machine learns on its own with its own experience. It's a completely different concept. We can't go into too much detail here. But now let's talk about a bit about application. So why do you think machine learning is gathering so much worldwide attention? It's because of its application. Now there are so many applications of machine learning that you're using in your day-to-day life that you don't even realize, right? For example, email spam filtering. Now, how do you think a lot of your emails go into spam? That happens because of machine learning. So somebody has created a software or a model that can actually classify whether this particular type of an email is a spam or it's a normal email, right? So remember when we were talking about classification problem, this is a perfect example of classification problem, whether my email is going in spam or not, right? So that's basically classification. So that can depend on multiple factors. For example, it can depend on the size of your mail. It can depend on the type of text you're using. So it depends on multiple features or multiple columns. Now, recommendation engine, I've just discussed, right? Creating clusters and recommending them, certain products or certain movies or anything that you want to say. Now, fraud detection in banking is a huge application of machine learning. Banks suffer tremendous amount of losses every year because of fraudulent transactions. So machine learning can help reduce that as well. Let me give you an example. Suppose you make a transaction today, or you go to an ATM and withdraw some money today at 9:30 p.m. from Bangalore. Now at 10 p.m., there's again some transaction happened from New York, from an ATM which is present in New York. Now our machine learning model can easily identify, okay, this is says there's something fishy, there's something wrong happening here because it's totally impossible for a person to go to travel in an hour from Bangalore to New York and make a transaction. Right, so that's one example. Speech recognition, I know most of you have heard about it. Google, pretty good speech recognition engine, whereas Siri, all those virtual personal assistant, how do you think they work? They have worked because of speech recognition, right? So these are a few applications of machine learning. There are many, many more applications of machine learning, guys. Who is a machine learning engineer? Now let's talk about what is a typical day-to-day activity of a machine learning engineer looks like, or what are the roles and responsibilities of a machine learning engineer. So now let's look at whatever we have written in the slides. We'll read out these points one by one. Running machine learning experiments using a programming language with machine learning libraries. Now, what does this mean is basically you not only need to understand a programming language, you also have to understand the libraries. For example, Python, which is most widely used machine learning programming language, right? Programming language for machine learning. Now, in Python, there are multiple libraries which are available for data manipulation, scientific and arithmetic computation, and machine learning algorithms. Now, you need to understand these libraries and then perform certain experiments on your machine learning model to get the output, right? So to get to understand, how you can solve this problem better. So you need to perform certain experiments there, which comes with experience. Obviously, you need to deploy machine learning solutions into production. There's no point keeping the machine learning model to yourself. You want to deploy it to production for the end user to actually use it and suggest you relevant feedback so that you can implement that and release it again, right? So you need to have certain experience over there as well. Now, feature engineering is another important part of the job. The raw data generally cannot be fed to the algorithms above directly, right? So you cannot just feed in the raw data to the algorithm. You have to pre-process it, which we just discussed, right? I won't go there again. Now, staying abreast of latest development is also very important because you have to understand if there is any latest technology which is out there in the market or a new way of solving a problem is out there in the market. And if it fits perfectly with your business requirements or the use case or a problem that you are trying to solve, then you have to implement it. I mean, so it just doesn't make sense if you're not implementing it, right? So recently, I read an article about capsule neural networks. So all these types of new techniques which are coming in the market, you have to make sure that you are aware of such techniques in order to implement that in your own company. Now, how does a typical machine learning engineer job description looks like? I've taken it from Uber, and I think it's the best way to identify what are the skills required, right? Because whatever the requirement of the industry is, you want to have those skills, right? So let's just read out this Uber job description quickly. So ability to translate a real life problem into a ML model. It's very easy to understand. For example, if I want to open a pizza store, now I want to open it at a location where I am able to tap into most of the local population. I also don't want to open it at a location where the most of the population can't afford the food, or for most of the population they're not even aware of Pizza Hut, right? So at there, you need to use machine learning model where you can create clusters of, localities which have a good economic background, and over there you can open a pizza store. So just one way to transform a real life problem into an ML solution. Now, practical knowledge of feature engineering, model training, model tuning, and model evaluation, etc., is important. So obviously, feature engineering, what are your important columns that you are going to use in order to predict something? Model training, how you're going to train your model, which type of algorithm is going to suit this particular use case. Model tuning is basically how you can increase the accuracy. Evaluation is finally what is the accuracy, right? Experience with designing a scalable ML system, including feature store, training pipeline, model serving, model deployment, experimentation framework. So it's pretty much the repeat statement of what we have just discussed. Now, demonstrated application of ML techniques in the industry for a problem at scale with fruitful results. Now, this is something which obviously comes with once you work on multiple projects, right? So yeah. Now, experience with machine learning libraries such as TensorFlow, Caffe, Theano, Scikit-learn, SparkML, etc. So it's very important, guys, that you know machine learning algorithms and machine learning libraries. For example, TensorFlow, then you have Scikit-learn, NumPy, Pandas. All those libraries are very important. Now, what are the important machine learning skills, or you can say the key takeaways from the job description that we have just discussed? First of all, you should have decent programming knowledge, and you should understand the important libraries which are used for data manipulation, scientific computing, numeric computing, and machine learning. Right. So you have to understand these libraries. So the most preferred programming language for machine learning is Python. Most of the machine learning engineers prefer Python, guys, because it is very easy to use, very simple to understand with a very easy syntax to follow. So even if you don't have a good programming background, don't worry, you can learn Python. It's pretty easy. Now you have to learn certain libraries in Python. For example, NumPy, Pandas, Matplotlib, which is basically Matplotlib is basically for data visualization because it's very important to visualize your data as well. Seaborn is also for visualization. Then you have scikit-learn for machine learning, TensorFlow for deep learning, right? So you need to have a good understanding of these machine learning libraries. Then probability and statistics is also very important. Data modeling and evaluation. How will you model the data? What type of algorithm are you going to use, right? How are you going to evaluate it? What is your like is a typical accuracy that you're targeting, right? So that is also very important. Now, developing and deploying a machine learning algorithm is definitely very important. What type of algorithm you're going to use, how you're going to develop it, how is your training data set going to look like, testing data set going to look like. So you should have good understanding of machine learning algorithms like regression algorithms, clustering classification algorithms. Regression algorithms can be linear regression, logistic regression. Then for classification, you have decision tree, random forest, all these algorithms. For clustering, you have k-means clustering, hierarchical clustering, all these algorithms. So you need to understand how the math behind these algorithms work. What type of problems these machine learning algorithms help us to solve, and which is the best algorithm which is going to fit in my use case or in my business problem. Now, how to become a machine learning engineer? Now, what are the steps to become a machine learning engineer? So just follow this roadmap, guys. It's pretty easy to understand, but decent, relatively hard to hard to implement. So you need to understand Python programming concepts, fundamentals of probability and statistics. You need to be very good with data wrangling, exploration techniques using NumPy, Pandas, and Matplotlib. Data wrangling and exploration means basically cleaning the data and understanding what are the features that I really need and what I'm going to predict. Now you do that with the help of libraries such as NumPy, Pandas, and Matplotlib. Matplotlib is for visualization. Pandas is for data manipulation, concatenating the data sets, merging the data sets, all those things. NumPy is for scientific and numeric computation. Now, understanding machine learning algorithms such as regression, classification, and clustering is also very important, which we have just discussed. Working on multiple machine learning problems, you have to work on as many projects as possible. You need to have that data-driven problem-solving approach, which the industry actually looks for, which only comes with experience. Now, there are certain add-on skills. Mostly companies won't ask these skills from a machine learning engineer, but it's definitely, it's a good thing to have these add-on skills, right? First is BI tools. So if you have good knowledge of Tableau, Power BI, or MSBI, or ClickView, or any other BI tool. Sequential query language SQL, you should be thorough with sequential query language and database concepts, and deep learning concepts as well. Knowledge of TensorFlow, how neural networks work, different types of neural networks, all those things. What is the scope of machine learning, and what is the salary that a machine learning engineer draws, right? So let me read out a few stats in front of you who have this question of how the future is going to look like for machine learning engineers. Now, 10 times more machine learning engineers are working today than 5 years ago. There's a 10x growth in the last 5 years that has happened. I don't have to stress much on this, right? Now, the global ML market value to grow to $20.83 billion by 2024. That's huge, guys. Now, almost 2.3 million to 23 lakh job positions to open up by 2021. Now, the number is huge, guys. The future is really bright for machine learning engineer. I would say it's a very important and an essential skill to acquire. So, average machine learning engineer salary in US is somewhere around 100 to 110 US dollars. Now, obviously, it varies based on your location, your experience, your skill sets, all those things. In India, I would say 20 to 25 lakh is what an average machine learning engineer should get. Can also be around 15 to 25 LPA INR. Now we have talked so much about what is machine learning, how does it actually work, what are the various types of algorithms available, how does the future of machine learning looks like, what is the typical job description looks like, what are the skills that I need to acquire in order to become a machine learning engineer. But now let's focus on how Verzeo can help you in order to become a successful machine learning engineer, or how it can set you on the path of becoming one, right? So Verzeo, as I've told you earlier as well, is India's largest internship and certification platform, right? Verzeo certification programs come with 100% job guarantee. Now, let me just quickly open the page and I'll show you that. Now, this is how the page looks like, guys. So you get really cool benefits once you enroll with Verzeo. For example, you get 100% job guarantee. You also get mentor-led live sessions from an industry expert. So he's not a trainer. That guy will be someone who has worked in the industry and has good experience in that particular domain. So Versio is basically an international brand. And once you're done with the course, you also get certificates from University of Texas Arlington, or you can go with Mississippi State University, or even University of Dubai. So these are our basically learning partners, or you can say you will receive certificates from such universities. Now you can see the concepts which will be covered as a part of this course, right? So NLP, statistics, everything will be covered from scratch. There are no as such prerequisites here. This is how the sample certificates will look like. These are the pricing plans you can go ahead and check out. Our alumni actually work at these many different MNCs. Yeah, it's a perfect way to kickstart your career. You also get a 100% job guarantee. So with this, we come to the end of today's session. I hope you have enjoyed it. And if you really think that this video was helpful, go ahead and click on the like button. Also subscribe to our channel so that you can get regular notifications on the videos that we upload. Thank you guys and have a great day. And don't forget, I'll be soon coming up with a video on what exactly is machine learning, how it works, and what are the various algorithms. So we'll be going into too much technical details and understanding how it actually works. Thank you guys and have a great day.